Okay, sir, can we start the session?
Yes, ma'am, ready to go.
Can I enable the recording, sir?
Yes, ma'am, start, ma'am.
A very pleasant evening to one and all present here. Be the change that you wished to see in the world. With this quote in this wonderful evening, to refresh and create an impact onto the mind, Department of Electronics and Communication Engineering, Saveetha Engineering College brings to you a webinar on Machine Learning Using Python by Dr.Doreen, founder and director, Computational Intelligence Research Foundation, Chennai. A glimpse of a college and department. Saveetha Engineering College, established in the year 2001, an autonomous institution which follows the Finland-based education model, and we march towards less is more concept. Our college makes the students job ready by providing Industry 4.0 ready curriculum, which impart the 21st century skills. Project-based learning integrated with subjects improves the student skill set and makes our learners to be the best, which is the motto of our college. The Department of ECE was established in the year 2001. Our vision is to develop the department into a state-of-art with Center of Excellence in Electronics and Communication Engineering education on par with global standards. The Department of ECE has well-experienced faculty of proven ability and diverse specialization. The faculty actively involves themselves in research in the fields of robotics, VLSI, MEMS, image processing, and embedded systems. Yes. Now I would request Dr. S. Nagarajan, Associate Professor, EC Department, to introduce our guest of the day. Please, sir.
Thank you, madam. It's my great pleasure to introduce the guest of the day. Dr. Dr.Doreen is a Director of Computational Intelligence Research Foundation, Chennai. She received her Ph.D. in Computer Science Engineering from Anna University. Her research interests include parallel and distributed computing, grid computing, cloud computing, and big data analytics. She has published about 30 papers in international and national journals. She had been the resource person for the workshop on digital classroom, big data analytics, using Hadoop, data science using Python, machine learning, deep learning, cognitive computing, and software testing. We are very happy to have with us today, madam. I kindly request you to take over the session.
Thank you, sir. On behalf of CIRF, I extend a warm welcome, and I would like to thank the management of Saveetha Engineering College, and especially the Department of ECE for having invited me for this talk on machine learning using Python. All right, so happy to meet you all on this session on webinar. So this season of pandemic enables many teachers around the world to learn and enrich content and technology. Right? As they have said, I'm the founder and director of Computational Intelligence Research Foundation, before which I was working for a set of engineering colleges, right? And the reason behind I started these research, I know most of your faculties could be some students too, all right? And most of us, we learn engineering, right? We learn engineering. At the end of it, every time we struggle even to install an operating system or coding for a problem that is for a new problem or for a new solution. So hands-on training is much more important. That we started this company called Computational Intelligence Research Foundation, wherein we basically work on technologies. Okay, we work for companies for finding our solutions for the research problems. We also train faculties, students, and corporates on research technology. So happy to have like 200 plus people on to hear this webinar on machine learning using Python. All right, so. And I think this is my 26th webinar during this pandemic alone. If you could go to my website and check it out, it is my 26th webinar during this pandemic. After the pandemic has started, so more webinars have been conducted. All right. So we'll go to the content of the day. So we will be seeing about machine learning using Python. I know most of you would have listened to the word machine learning. All right. And before going into the topic, you can share your concepts in your chat session. All right. And what was your visualization on machine learning?
Ma'am, actually participants are not allowed to unmute, ma'am. They
No,
share their
in the chat session. That's what I'm asking. In the chat session.
yeah, ma'am.
Yeah. You can just type it out. What are some words that reflects into your mind when you hear the word machine learning? You can just type it out, your answers in the chat box. Able to type it out? Yeah. Yeah, you can use your chat session. Yeah. Neural networks that self-correct. Thank you, Abhishek, sir. Let's hear from a few more people. What does that reflect your mind when you hear the word machine learning? Let's be a little quick. Just 1 or 2 words also is enough. Okay, machine learning method of data analysis. Making the machine to learn by giving inputs exactly right, Saveetha ma'am, is. Now, my next question, okay, deep learning is different, machine learning is different, okay? So you can check out in my YouTube channel. I've done a series of lecture on machine learning and deep learning, okay, and then the difference. All right, for this session, we are going to focus on machine learning, all right? So each of you have given some words, okay, what that has reflected your mind when you hear the word machine learning, okay? So before machine learning, we had I'll come into it, how the history came, and then we'll move into it. To control a device through software. Thank you, Mahendran sir. My next question, kindly listen carefully, and then you can respond it in chat boxes. Okay? You can respond it in the chat boxes available, all right? What are some applications, like day-to-day applications that involves machine learning? Applications of machine learning algorithms in a day-to-day life, or some gadgets or any equipments that you would have seen that you could think that this device or this equipment uses machine learning. Netflix, all right, correct. Few more. Robotics. You can be even more specific also. Smart home applications, all right. Alexa, right. Xbox, right. Chat boxes, smart door locks, exactly. Some houses, they have a face recognition software. Only the people who goes into, if the face are recognized, then the door unlocks. Yes. Even simple applications, right? If you, I know everybody will be using your washing machine, okay, or your fridges, okay? Yes. So Siri, all right, Siri, yes, that uses machine learning, all right? So when you take, for an example, washing machine, okay, we just load a washing machine, will have how many kgs, is weather forecasting exactly right, Dr. Sumati ma'am, okay? So when we load our clothes into it, then we define whether it is a cotton, or it is a wool, or it is a silk. And then we also give is online fraud detection, an immense research topic, okay? And we have worked in a company for a couple of people on fraud detection on both machine learning and deep learning. Okay, thank you all for your responses. So if I feed my clothes into the machine, then my machine will do the washing machine. So it has got the process of cleaning the clothes according to the fabric. And also I can set the time and whatever it is. Once all these inputs are given, automatically the machine started cleaning my clothes. So these are some examples. Today we have so many examples, like and speech and object recognition, yes, pattern recognition, yes, ma'am. Yes, ma'am. So like that, so many things are there where we train our system. So the reason began, how are we going to train our system? And then how are we going to train in such a way that we could get the desired output? Okay, the way that in which we get the desired output is what we'll be seeing about machine learning. Medical diagnosis, a lot of research, even currently some researches are going on even in our lab. Okay, so here, before doing analysis of data, we need to visualize the data. That's the first important step in machine learning. Before we jump into the algorithm, we should know what is the data that we're going to analyze. So data analysis plays a very vital role, okay, plays a very vital role in machine learning. Today we are going to see the steps how to write a machine learning, and we will see you some demos of both data visualization and machine learning algorithms to the best possible. Okay, so whenever you have got doubts, you can put it on your chat box, so we'll be able to get it out. Okay, so we would have been seeing, before we start with the machine learning algorithm, we need to correctly analyze the data. What is the data? What are the data available? What is my data set? So before going to that, you will be defining what is a problem definition. Okay, for the particular problem definition, you're going to derive a solution for it. All right. So when you are going to derive a solution, you're going to test with the data set. So the data should be perfectly analyzed. So for that, in Python, we've got plentiful packages, out of which I've just handpicked 5 packages. Okay, I just handpicked 5 packages. The first package is NumPy. Okay, NumPy, some of you would have heard about it. It is called as numerical Python. And the second is called SciPy. Okay, SciPy is called a scientific Python. Okay, so if I want to work with numerical analysis of data, like Laplace transformation, Fourier transformation, okay, so whatever it is, even hardcore, okay, hardcore mathematical problems are being formulated, and the solution are also embedded into NumPy. So just like that, you should know how to take the packages, how to use this function and give proper inputs, and you will get the answer, right? And SciPy is for most of our scientific applications, and Pandas is for Python for data analysis. So Pandas plays a very vital role. Using Pandas, when you have got a data set of maybe an Excel, of a data set of your CSV, or a data set of any format, you can drag it into your Pandas. So the data type of Pandas is called as data frame. Okay, the data type of Pandas is called as data frame. Even when I have a data on my website, just like that, I can drag my data into my Pandas. All right. So Matplotlib, as the name suggests, okay, it is used for plotting your data. Okay, it is used for plotting your data. And the final thing we'll be seeing is about Seaborn. This is also a data visualization. Seaborn is like advanced machine Matplotlib, and its visualization will look even more better and pleasing. Okay, so more facilities are available in Seaborn. Okay, then we'll be seeing about what are the steps involved in machine learning algorithm, and at last what are the evaluation metrics that we'll be seeing. So this is about the flow of your event. Before going on to that, okay, if anybody had worked on machine learning, and you just type in the chat box like what type of algorithm is used or for what application. Just 1 or 2 words. I know there's plentiful faculties. All right. You should have worked. If you have not worked, also you can say just like that, I'm new to it. Yes or no? If yes, what is that? If you're new to machine learning, you can say. If you have not worked in machine learning algorithms, you could have typed no, thank you. Because you have been expertise in another domain, right? So everybody we can think. So if you have worked in machine learning, just put on the chat session. What is the type of algorithm you use or for what application? If it is new, yes, thank you, Monica, ma'am. You're new to this. Yes, near K, nearest neighbor algorithm. Thank you, ma'am. Yes, Saveetha. So some of you are new, for some it is new. So the first packages, okay, the first packages, whatever I said about NumPy, about SciPy. NumPy is numerical Python, SciPy is scientific Python. Python for data analysis, we go for Pandas, all right, and then Matplotlib and Seaborn. Okay, matplotlib and cpon. Okay, now we'll move into, because you have asked, right? So classification algorithm. Thank you, Nitya ma'am. So we'll be seeing about what is artificial intelligence. Most of you would have taken a course on artificial intelligence also. So artificial intelligence, as we say, machine being able to carry out our tasks in a smarter way. It covers anything that enables a computer to behave like humans, but computers cannot be like humans. Okay, so in humans, you can always expect the unexpected. Okay, you always expect the unexpected. Nobody thought, okay, we'll be into a home for 100 days without going out. Anybody ever imagined in your life? If you have imagined this situation will occur, yes or no? Yes or no? Anybody imagine? No. Yes, Dinesh. Nobody imagined. Nobody imagined that we'll be into our home. Yesterday, we have successfully completed 100 days of complete lockdown at home. But still, because we are human, we know, because we are not going out, but still we are able to cook, we are able to eat, we are able to survive. But machines are not like that. So that is what the main difference between machines. And you can train, even the technologies can come, but they cannot replace humans. So artificial intelligence, you make the machine to work. Okay, that was the first set. The subset of artificial intelligence is called machine learning. The idea behind, you have to give data into your machine. Okay, and make the machine to learn, but they need some support of human support to diagnose the results the machine gives. So we need to train the data sets. Okay, we need to train the data sets for a particular application, and we need to analyze the results what we got. It is mostly used for extraction of patterns. If you have got a large data set, if you want to extract your patterns, say for example, most of you are faculties, right? Most of you are faculties into different colleges, okay, into different colleges. So when we take our students for the first day, first year students, very obliging, very obedient, because they're coming directly from school, all right? So that time, we will not know the pattern of students, whether the student learns well, whether the student is okay. We treat everybody the same. Okay, as and when we go to the class, by the end of the first semester, I can even clearly demarcate, so these are the students who learns well, these are the students who respects well, these are the students who are putting effort to learn, these are the students who are not giving any effort. Okay, so how many of you recognize by the end of each semester about your students? Yes, no, no, yes, if yes. By the end of a semester, whether you're able to diagnose the patterns of students. Exactly, yes. So you have been trained, okay, you have been trained because of your experience. See, if a faculty is 20 years experience, by seeing the student itself, they can clearly diagnose. Yes. So if it is a fresh year, it takes time to learn the patterns. But anybody, by the end of a semester, within 3 months, we'll clearly able to find the strength and the weakness of a student. So we are going to extract patterns. So that we are doing it humanly. The same thing we are trying to do it here. Okay, the same thing we're trying to do it here with the machine that could learn. Okay, so what is machine learning algorithm? That parses the data. So how will it parse the data? If I'm going to have a set of data, say for example, I'm going to have data for sales. Okay, so these are my data of sales. So these are the sales representatives. These are the methods I have generated my sales. And then for these many sales, it is a 1, and these many sales, it is a loss. If I just feed my data set into my system, my machine learning algorithm should need to parse the data. First step, okay, algorithm should need to parse the data. What are the types? That is the different columns that you have. If it is a normal text file, if I'm going to fit into my image, say what are the types of segments, what are the objects that they are there, okay, that. So if I'm going to take a video, from the video I can take what are the objects that are moving, objects to be detected. So algorithm that parses the data, that's the first step in machine learning. Second is most important. Here is where your machine learning algorithm works. Okay, we have to learn from the data. Whatever it has been given from the data, these algorithms should keep on running on different, if it is classification or it is going to be clustering or it's going to be regression. From the data, we need what is the algorithm that we are given to train. From that, it has to learn from the data. Then whatever the patterns of the data that has been diagnosed, the patterns of data that has been diagnosed by the algorithm will be applied to make us an informed decision. The same example, if I'm going to feed into my data of the marks of students, so my machine learning algorithm will try to find the marks of the students maybe for 3 internals, and by the end of the internals, my machine learning algorithm will tell when the student goes for the final exam whether they will pass or fail. Okay, it has to take an informed decision. If I'm going to feed my data set of a medical, okay, patients with tumor and without tumor. So once I give my data with and without tumor, once my machine learning algorithm is trained with both data, and then if I'm going to feed into a data, it will tell me whether this patient has got a tumor or not. So the weather forecasting. So many applications I can keep on saying. So when it is trained in such a way, it will give us an informed decision. So this is all about machine learning. So first we have to parse the data. Second, this is the most important. You have to learn from the data. What are the data that is available? And then making an applied. Then we have to make an informed decision. Is it clear to now? Any doubts? Yes or no? Is it okay? Okay. Okay. So everybody, right? No doubts. Thank you. So we have an example. Okay, I know everybody nowadays people have land or house, but everybody has got a Facebook, everybody has got WhatsApp, everybody use YouTube. Yes or no? Is there anyone attending the session? It's not using Facebook, it's not using WhatsApp, it's not using Telegram or Instagram. Most of us we use, right? So most of you, how many of you bought some even things in Amazon, Flipkart, or any e-commerce sites? So when you buy, say for example, if I want to buy a mobile, okay, when I search in Amazon to buy a mobile, though I'm going to buy it or not, simply I'm just logging in, I'm just figuring out what are the products available. Can you see down some recommendation systems? Sorry, can you see the people who have searched these items has also searched the items? It will be exactly the same, but of different companies and different variations in the specification. How many of you tried in Amazon or Flipkart? Because there's a more predominance, there are even more websites available. Yes, no? How many of you have seen down the same kind of products? Yes, thank you, Jayad sir. So you all have seen that means your recommendation system algorithm runs in your website. Okay. Yes, I have seen it. So from the application, so the algorithm learns the pattern of data. What kind of product you're going to buy? So once it is already be pre-trained, okay, the algorithm is pre-trained. So if you know, we also that recommend in apps also, yes, it is pre-trained. So this is the product, which means this product also they're expecting. Able to understand? So that is what is an example of recommendation. So a lot of application uses recommendation system of both machine learning. Now it's still advanced, and most of them are moving into deep learning. Yes. My next question: how many of you have seen YouTube? When you see a video in YouTube, can you see the next video that plays be almost relevant to the video that you have played? Yes. Is, which means even a recommendation algorithm runs in your YouTube. Yes, yes, I've seen Sneha. So when you run a YouTube video of your, nowadays I know every house, right? Though they are cooking or not, whatever they are going to cook, every house, the most seen videos, okay? The most seen videos, I'm just taking an analysis. What's the most seen video in your YouTube nowadays? Yes. Most seen videos. Okay, mostly it is recipes. Cooking, biryani making, cooking recipe. Yes, yes. You see one video, the next video comes. If I'm going to see how to prepare a kesari, the next video, if I say for example, same biryani, the different types of biryani comes. So which means a recommendation system. So you're that is making to make, yeah, even music, lots of applications are there using music, how to bake a cake, though we're baking or not, we see it. All right, thank you for all your responses. Right, so make a decision of new machine learning algorithm associates the listeners prefer. So if I'm going to like a jazz music or pop music or Johnny melodies, accordingly it gives. So now we'll go into the Python for data analysis. Okay, so we'll see a overview. We'll see overview of Python laboratories, and then we'll see how to select, filter the data, how to manipulate. I told right before you start with your machine learning algorithm, the most important thing is data analysis. So how to plot the descriptive analytics and inferential analytics, statistics. We cannot go more into its detail. I just give you a nutshell. So the most popular libraries I told. Okay, these are the things that will be seeing you. And I told about NumPy, SkyPy, Panda. So scikit-learn. Okay, scikit-learn is a package where lots of machine learning algorithm has already been written and embedded. So in the starting, some professor told they worked with regression. See, they worked with regression. So all the algorithms, regressions embedded in scikit-learn. So moving on to my NumPy. Okay, it introduces object for multi-dimensional arrays. Even if I give an image, from the image, an NumPy array can be done. Okay, so that allows easily to perform advanced mathematics, because I've given lectures on image processing. Okay, especially using OpenCV and normal image processing. Whenever free, you want to learn about, you can visit my YouTube channel and you could learn it. Okay, and also it provides vectorization of mathematical operations. Okay, for all kinds of mathematical operations, you can work on NumPy. And for linear algebra, numerical integration, differentiation, okay, that can be done using a SkyPy. And this is most important, which is called pandas. Okay, Python for data analysis. You can add a structure and tools to work. Okay, and that you remember what is the data type I told that works with pandas? Anybody remembers the data type? Okay, it provides the tools for data manipulation, how to reshape, how to merge, how to sort. Yes, thank you. Hands off to Nandini ma'am. The data type is called data frame. Thank you, Nandini ma'am. And also, if you're missing data, it will be very difficult for your machine learning to run. So we need to create the data. Data creation is one of the important steps. So in scikit-learn, it provides machine, like you should know for what application, what to apply. That's very, very important. Okay, for applications, for some application, it's classification, whether the patient is sick, has got a disease or not. That comes into classification. If it is a continuous variable like stock, exchange, or gold price, then you go for regression. For clustering model, if you have got a set of students, if you want to cluster them, those above average, average, and below average students, then you go for clustering. And after you model your algorithm, you need to validate it. So a lot of validation has been done using model validation. And this, can you see? First, we started with NumPy, SkyPy. SkyPy is built on top of NumPy. And then we saw about Matplotlib, and scikit-learn is built on top of NumPy, SkyPy, and Matplotlib. Okay, Matplotlib provides a two-dimensional plotting library. Okay, it's similar to MATLAB's, but it is more advanced in MATLAB's. All kinds of plots, all kinds of plots. Even if I give you a 10 lakh of data, you'll not be able to go through one by one. But if you've got a visualization, you'll be able to do that. And quickly, I just show you some visualization that we have done for COVID-19 data analysis. Okay, and then Seaborn based on Matplotlib. Okay, it is again based. I told right, it is like advanced to Matplotlib. All right, and then it provides a high interface. Okay, so these are the different packages. This is how you'll be importing NumPy as NP. SkyPy, SSP. This is just aliasing. You can give any names that you would like to give. Okay, you could read a CSV. So using pandas, since I imported pandas as PD, okay, I am reading it like PD.read because my data type is a CSV format. I know you will know what a CSV. It is called as comma separated values. Okay, I can also have my Excel data set to be incorporated, a dot data file, or whatever it is, even if I have, I don't know how many of you worked in big data analytics using Hadoop. We have done lots of research using Hadoop. So once my files are into my Hadoop distributed file system, directly from that also I'll be able to take it. Okay. So before moving on to the steps, I'll just show you. So here I've just imported directly from a website. I'm importing, okay, the sales data set, which is win and which is loss. Okay, so when I run, I'll get a start, and then from all my data I'm getting to my URL. From the URL variable, I'm putting into another variable called sales data. So all my values will be into my sales data. Once the asterisk goes off, which means it is running now. Okay, it has been run. Now I'm going to get the data shape. So it has got 78,000 rows and 19 columns. You see, I have not stored the data anywhere in my system. Just I'm going to URL, dragging the data into a variable, and from the variable I'm just passing into my CSV. Okay, I'm passing into my CSV into my pandas. Okay, my pandas, because the value whatever I'm giving is a CSV file. Can you see here? It's a CSV file. So it has got these, and using this pandas, I told right, panda is used for data analysis. So I'm just using the head will give me the first 5 datas, and the tail the next few data. So can you see it is 78,024, and my first value is 0. Okay, so totally I've got 78,000 rows and 78,025 rows and 19 columns. This is about a 6, whether the sale is a 1 or it is a loss. Okay, so here, and then I can see what are the data types that is available, because I've just like the taken it. I can see what are the data types that is available, and data dot describe. Okay, data dot describe will tell me about only the integer values, only the numerical values. Can you see here? It's objects. If it, say for example, if I'm going to take this data type, supply subgroups is an object, which means supply subgroup. Okay, it's an integer, it's a string. So using string, I cannot use the function describe. Okay, describe is this function where it computes the variable which is of integer type. It could be an integer, it could be a float, but for strings it will not take. Okay, so here I'm just taking the mean, standard deviation, minimum value, the count value. You remember I told about sorry, I have not shared this. Yeah. So this is the screen. Can you all see the screen? Yes? Okay. Yeah, sorry. So I just imported my pandas from a website. All right. And then I'm taking into my pandas, import pandas as PD. I'm taking a CSV file that is on my website, on one of the website, and then I'm finding the data. So okay, it is totally 78,025 rows and 19 columns. So you can see here a mixture of text, data type, and also string data type. So dot here, because I've taken all the variables into the sales variable. Okay, I'm going to use sales dot head of the first few lines, sales dot tail of the last few lines of my data set. And also I could see, I told right, data analysis is more important. It's more important. And here what are the data types, and I can use the function like describe. Okay, and I told you about the Seaborn. Okay, I'm importing both Seaborn and matplotlib. Okay, so I'm using the function. So from the data, so 78,000 rows, I'm going to take only one column. Okay, route to market. So this data set is about we are making a car accessories. Okay, and the product is being given to the market to sale. So in car, if I'm going to have a car, I will not always go to the specific shop. I can buy it from anywhere. So how it is routed to the market? Can you see here? The product, car accessories can be moved to a field sales, a salesperson or a reseller. So different variables will be there because it has got 78,000 rows. Okay, and then this is more important. This is my target. This is more important. All right. So whether the sale is won or lost. Okay, that is what is my target. Whether I'm going to won my sale or not. Okay. For that, I'm just showing a visualization. So I have all my values into my sales data. Okay, I'm just going to take my x-axis. I don't know because I didn't run through everything. But using this graph, I can find what are the unique values in my route to market. How the product is routed to the market, either through field sales or reseller or through other routes to market. There are several ways, or to telesales, television advertisements, or using tele coverage. Okay, and I can see here it is one of. So in one shot, I can see the most one in my sales. So the best route to my market is the reseller, where they won but losses is most in my field sales. So for these, before you run with an algorithm, I'm going to predict it. Okay, I'm going to predict it whether my data set, whether my sale is going to win or lose. And then this is another visualization called as a violin plot. Okay, here I'm taking one loss and I've taken client size by revenue. Okay, and this is what data visualization is very important. I've got plentiful of applications, but due to very less time, okay, generally I do hands-on session. Okay, in our company, we just completed last month, we completed a hands-on session on machine learning using Python, because whatever we hear, that is not going to, we can understand the concepts. Okay, we can understand the concepts, all right. But most important, and also most of you have seen YouTubes also. When you see a YouTube recipe, it will be very good. Okay, it will be good to see. But only when when you try your own recipe, it will not be the same as you have seen. So same way, I always encourage the faculty members to get yourself trained on hands-on training. Okay, so you try to code on your own. So then through you, like thousands of students also will be trained. So here, this is another example of a COVID-19 data set. Right? We have taken the entire complete COVID-19 data sets. Okay, I'm taken into this variable called a DF. Okay, and I can see like from which country, from which province. You know about latitude and longitude, will tell me from which location, right? And I've just taken it and I'm describing it. How many countries? Okay, it is 22,000 countries and this many regions. I'm just finding the count of each country. Okay, and then I'm finding the describe. I told, right, only how many have confirmed, how many deaths, and how many records. Just I'm counting it, counting the number of variables. Don't think the count. How many counts confirmed, how many deaths. So I told you, you remember, you should not have any missing variables. If you have a missing variables, then it will be your machine learning algorithm will not work. So I'm checking whether there is any missing variables. No. Only in province, so I will drop my province column. So from my data set, I've got my data set, how many have confirmed, how many death, how many recovered. So I will find, from if I delete, if I subtract my confirmed with my death and recovered, I will know what is my active cases. So I'm doing my simple data analysis and I'm showing a visualization plot. Okay, so when I click on which country, okay, when I click on the country, so it will say, so it is in China. It is in the first day. Okay, can you see it is 20 to 1 on the days. Okay, so and also I can see the active cases from a data set in Russia, in Egypt, in India. Okay, so I can also do a scatter plot. In one visualization, I'll be able to see. So if I click on India, what at this latitude, longitude, how many recovered. If I go to UK, okay, for Canada, Netherlands, all right, Panama, all right. So which country, wherever I go, it will be able to show me, all right. And next, death count. How many people have died in each country? and I can see like in Canada, okay, how many people have died. So it's a normal CSV. From a CSV, like how through the world wide, what are the total cases, okay, how many confirmed cases, so which is the top 20 countries, okay. But by this data set, I'm not going into deep, but I can see like Ireland was low. It was this analysis I've done a long time back, okay. It is like a mid of the pandemic. So US was high, okay. So topmost, which are the active cases, okay. So much and so much analysis could be done. So I'm going deep into it. Now I'll move on to my slides, okay. So this is how you can read your data. I can give an entire lecture on data visualization itself. All right. And now we'll move into machine learning algorithms. Okay, what are the basic steps for machine learning algorithms? Okay. Machine learning algorithms, okay. You have to define a problem, okay. You have to define the problems before you work on with your machine learning algorithm. What is an algorithm that you're going to run on through, okay. And even the entire session has been streamed onto my live channel, also YouTube channel. Those who are viewing it, you can give a like or you can subscribe. And eventually I've got 3 to 4 events that is going on. 3 to 4 like 5 webinars have been lined up till July 10th. Okay, so whenever I come online, when you subscribe to my channel, you'll be able to know. If you want to enrich your knowledge, I'm just sharing what do I know, and if you want to get benefited, you could get benefited. All right, so you can just try it out. So we'll move on to the machine learning major steps. The first is we have to clearly define the problem. What is the problem that you're going to address? And according to the problem, you have to create your data. And the data should be definitely a benchmarked data, okay? The data should be the benchmark data. Okay, I will share the YouTube link by the end of the session. Okay, let the session go. By the end of the session, I'll share you the link. Okay, and then the most important thing is that we have to prepare. What is the benchmark data? You have got a lot of repositories which means when you train or use an algorithm with those particular data set, it will clearly tell you whether this application, that the algorithm that you have developed, best suited for all types of data sets, right? So when you create your own data set and when you try to write your algorithm, you can create your data set according to your desired results. I repeat it. When you create your own data set, you will create a data set accordingly for your desired results, and you can tune your algorithm. So that data set, if you use, it will not be accepted by research. All right. So when you want to do a proper research, you should use your benchmark data set. There are different sets of benchmark data sets. So using the benchmark data set only, you should start working with your algorithm. So you have to prepare the data accordingly, and then you have to evaluate it. Okay, after you prepare your data, you will evaluate different algorithms. Like one classification has got bundles of classification algorithms, out of which algorithm will suit. So I tell this everywhere I go. So you cannot just stick on to one data set, one algorithm, you get a result, you can publish a paper. Definitely no. Able to understand? Try to take for a particular problem, try to take 2 to 3 data sets. Okay, 3 data sets. Maybe it could be a 50,000 rows if it's not a CSV, 50,000 files if it is an image, and next could be 2 lakhs, and next could be 10 lakhs of data. Once I feed all these data sets to different set of algorithms, don't stick on to one algorithm, try to have different algorithms. Once I feed it, and then I analyze my results using my different performance evaluation metrics. Okay, so first we need to install Python, SciPy. We have to load the data set. We have to summarize the data set. We have to visualize the data set. So that is what I told you till now. After installing Python, for loading data set, what is the package we used? Anybody you remember? It's called Pandas. And then for summarizing and data visualization, we used a Matplotlib. Okay, and lots of different visualization too, but visualization is more important. The same example I showed you, right? For the data set of sales, which has got 78,000 rows, I cannot go into each rows and find what is the route to market, whether it is a one house. Just type and with that, within few seconds, I can find through which route the market has got the good sales. So visualization is more important. We'll again go back to the same data set. Okay. Then we have to evaluate using some algorithms, not one. Most of them you're failing in research because you just figure out one algorithm, right? And we have to make some predictions. So there are different values. It's called F1 score, precision, recall, okay, ROC curve, AUs, okay. So the different curves are there. So there are different plentiful performance metrics from which I will show you different metrics that is needed. So once you get your result from the metrics, the best metric is called accuracy, okay. That should be taken. So I'm taking the same data set. Yeah, I'm taking the same data set, but what is the opportunity number? Oops. The supply groups, the route to market, so my target, and most importantly, you have to split your data. Okay, you have to split your data to be data and target. So I've got my entire data set. What is my target? Anybody remembers what is my target? I told. Anybody remembers? Yes, it is my opportunity win, whether my sale is going to win or not. So from my algorithm, from my data set, okay, from my data set, I'm going to take all my values as data and test. Sorry, data and target. Okay, before going into the step, the first step is that if I have any size of my data, I have to split the data into training set and testing set. So training set and testing set. Generally, they say if I give 0.3, it will be 70%, 30%. If I give 0.4, it will be 60% of training and 40% of training. If I give the value as 0.2, then it will be 80% of training and 20% of training. So, and this is more important. Okay, then once I split my data into training and testing, and each training and testing I'll be splitting into data and target. So all the rows, all the columns will go into data. Only my target, because it is a binary classification, only my target will be whether the sale is won or not. Same thing in my testing phase, I'll have my entire data set that is split into data and target. All the column values will be in my data. Only my opportunity results, whether it is won or lost, will be in my testing set. Okay, so so first we have to curate the data. That's what I did. We have to fetch a data set that we have done it. Curation, finding out for missing values, and this is more important. The next step is we have to convert a categorical value into numerical values, because when your machine cannot understand strings. Okay, if I'm going to have a traffic signal at red, yellow, green, no, my system cannot. I have to map my red, yellow, green to 0, 1, 2. It is easy for less. Say, for example, if I'm going to do a weather forecasting, I have to fetch all my data from my satellite, which will have multiple number of values, and I will not be able to do mapping. So that's a package, okay, for pre-processing. So you have to convert all our categorical data into numerical data. You have to do a feature extraction and normalization. You have to transform for use with machine learning. So pre-processing and feature extraction can be done manually, and there are plentiful algorithms for feature extraction also. The exploitative data analysis is what I showed you. Then next will be a machine learning, and then that is what I told we have to split into a data set and testing set. Okay. Maybe if I have time, I'll come into this. Now I will move into. I'll now show you how it works. For the same sales, you remember we have 10. I told, right, the first step is pre-processing. So if I'm going to have, I'm just figuring out the columns which have all got my strings, because most of them it is of numbers, so it is okay. It is okay, but for some it was on strings. With strings, I told you, you have to convert all your categorical data into numerical data. So I'm converting my route to market. I'm finding how many unique values are there, and then I'm converting that into, okay, I'm converting that values, okay, using a pre-processing label encoder. So can you see here, it has got like car accessories, external accessories, performance. After I compute this label encoding, it's all my values are into numerical. So now I'm fit to start with my machine learning algorithm. So I told you I have to split my data into data training set, testing set, and again both should be data into data target and data and target. Okay, so I'm going to have all my values into my data. Okay, I'm going to remove my results. Okay, I'm going to remove my results. So I'm going to take that value into target. I'm going to take that value into target. So I'm just splitting entire data into data and target. In target, I have everything. Okay, you will not see opportunity results like won or loss. In target, I'll have, if it is 0, it is loss. If it is 1, the sale is won. So here I told you the next step, I have to split my data into training set and testing set. So here basically every time I give 0.3 for when, because I worked even with 10 lakhs of data also, but I predominantly think that 0.3 works very well. But splitting my data as training set, I take 70% of data. For testing, I take 30. Some of you would be wondering what is training, what is testing. In training, I have both my data and target, all my values and whether it is won or loss. Using my training, I will train my machine learning algorithm. Okay, that's the first phase. So in my testing, I will give only the data. I will not give the target. Listen carefully. In my testing space, I'll give only my testing data. I will not give my test target. Okay, once I give my test data, it will run and tell me, because my test data will have only my sales value, not won or loss will not be there. But my machine learning algorithm, what I have given, will tell me whether it is won or loss. Okay, once that is given, that value is called as predicted value. So I'll get my output of predicted value. Already I have my actual data. So I'll compare both. When I compare both, I'll find the accuracy of my algorithm, how it has been trained. Okay, I repeat it. In my training set, I give both my data and target. It will be trained and it will find the patterns and key. The next step, I'll give only my testing data, not my target. In my testing data, when I feed into my machine algorithm, it will train, it will run, and it will tell me whether the sale is won or not. So I get my predicted result. Then I take both my predicted result and my actual result, and I will find the accuracy. Okay, I'll cover the questions. What is categorical value? Categorical value is values other than numeric, like strings, it cannot use. So I have to convert it into numerical values. Can you elaborate on feature dimensional reduction? So if, for example, if I'm going to have a multi-dimensional data, okay, I have to reduce my dimension to have a more concise result. Say, for example, the same. If you're going to ask in your college student database system, you'll have the student, but your objective is to find the academic performance of students. But your student data will have his name, his address, his father name, his mother name, his blood group, his mobile number, his date of birth. Then it comes to semester 1 mark, semester 2, semester 3, semester 4. So when we are going to do a risk analysis, academic performance, the parameters of his, we need his name and his roll number. We don't want to know what is his father name, his mother name, his blood group, his email ID, his mobile number, all such things that can be removed. That is called feature dimensional reduction. Whatever it is not needed, you can remove it. Okay, remove it. Okay. So now next I'm splitting my data and target. So data, if I'm going to have, see, I've removed I've made my 78,000 data. Okay, my data and target I've given into 0.3. So 70% has been taken in my data train and data test and target train and target test. Okay, so I'm splitting my entire data. So when I take my data, this 54,000 and this data and target will be given. Okay, data train and target train will be given to my machine learning algorithm. Okay, will be given and it will run. Okay, and for my testing, I will give only my data test, only this 23,000. Okay, these values when I give, okay, when I give these values, then it will give my predicted results. Okay, then, so this is my target. The row values also will be the same. Here I am using a Gaussian naive-Bayes algorithm. Okay, so once I'm giving only my data train and target train, predict is my data test. You cannot find my target. Okay, you cannot find my target test. So I'm giving it, and then for my accuracy, all these values will be in predicted. Okay, all these values will be in predicted. So when I test both target and predicted, I'll find the accuracy 75%. Okay. So I'm using the next is SVC, which is support vector machine, but the accuracy is there. So for this data type and for this algorithm, Gaussian naive-Bayes is better than SVC. And then And the next we will go for K neighbor classifier. So in K neighbor classifier, there is, so out of these three I can find the accuracies more. So when I take a machine learning, we have trained, we have run into the algorithm, but performance evaluation is very important. For here I use a prototype of a model visualization model called as classification report. So I told you, right, these are the three basic parameters of your classification of the precision value. How was true positive, true negative, the false positive, and false negative. So how truly it was true, and the predicted is also true. It was true, my predicted is false. So there is a lot of calculation that runs behind, which is called precision, recall, and F1. Okay, and so precision, recall, F1 score. All right, and confusion matrix. How many true positive, true negative, false positive. So actually these two diagonals are the correctly predicted value, and these two diagonals are wrongly predicted value. So it probably speaking, this value should be more and it should be 0. This value should be more and this should be 0. And I told you about ROC curve, and it will go in even more deeper into it. Now we will move into my I'll come into. So whenever you see your weather forecast, okay, that runs with your prediction algorithm. Okay, a lot of prediction algorithm are there for weather forecast. Okay, so if I want to classify whether this person has got a disease or not, then I go for classification algorithm, like example, a spam detection. All right. For a spam detection, so algorithm like SVC, KNN can be used. Okay, so for dimensionality detection, once are asked, you can use like kernel approximation, LLE, spectrum embedding. You can use those, and also for clustering. If you're going to use for clustering, then you can go for spectral clustering. If you want to know the different types of categories. Okay, so regression, I told it will be used basically for our continuous variable like drug response, stock prices. Okay, for these algorithms. So you should know for what application, what data set, what algorithm. Both should go coincidingly well. Then only your application will work. For clustering, for custom segmentation. So you know when you go to a particular shop to buy every time your accessories or groceries. So the particular shop, this is the most. Before you go into a shop, they'll say, "Madam, come inside. Come with the product as there." If you go to a shop, okay, for a dress shop. Now for 100 days, no dress shop. Okay, before we'll go to a dress shop. Okay, how many of you have experienced this? If you go to a new shop, they'll just say, "Yes, ma'am, come. What you would like to have?" But you know, go to a shop where you go frequently. You say, "Ma'am, this new product has come," and the salesperson will also take and show you the dress materials which you love the most. Yes or no? Yes or no? How many of you have experienced this? You go to a shop. Frequently, we go to a shop, they will know what is the taste of your dresses. And when you go into, the salesperson will try to take you to the shop of yes. So that is how they humanly segment. So like customer segmentation algorithm from your patterns when you go and buy. Say for if you're Christian, you go and buy during Christmas. If you're Hindu, Diwali. If you're Muslim, then you go for Ramadan or different thing, right? So you can, if you have your machine learning algorithm as the business generator, they can give you offers accordingly also. Okay, so that could be done. Okay, that uses K-means algorithm or spectral clustering algorithm. Okay, even I've got demos, but we have very less time. We are almost running to completion. All right, so dimensionality detection, that is what you said about a PCA feature selection. Okay, model selection. After you get your results, you have to find if it is not good, you have to hyperparameter tuning, like cross-validation and good search mechanisms can be done. So there is a lot of classification, like you can use like GLM, SVM, discriminant analytics. Okay, K-neighbor. Some of you have told you worked with the nearest neighbor according to your neighbor. So if you take Tamil Nadu, we speak Tamil, Karnataka they speak Kannada, Andhra speak Telugu, Kerala speak. So how it was, now it's universally we speak English, but using the patterns that also can be done. Okay, naive-based decision tree and ensemblers method. And there are two things. Some of you will have about what is supervised learning and unsupervised learning. All right. So supervised learning, you know what is your data. If I'm going to give you, since I gave you the sales data with all the columns, you know what is the data. So I'm just giving my raw data. Okay, it goes to my training. testing, what algorithm I'm processing it, and when I give an output, so I'm just training. It is just finding only the patterns. Okay, just finding only the patterns. Shape will be like this. That is what I told at the start. Machine learning algorithm will try to find the data patterns available, the pattern of data in a data set. I repeat it. Machine learning algorithm will able to find the patterns of data in a data set. Okay, the ones that is done. I'm just for testing, I'm giving another data of a green apple, but still it is able to tell me an apple, which is supervised learning, because I know my data set contains apple. What is unsupervised? You're just going to feed in your data without no headers. You don't know anything. The machine itself should run with your data and try to find the patterns of the data. Then they have to parse the data. You remember I told parsing of data in machine learning, it will automatically parse it. So here I'm just giving apples, bananas, and mangoes. It's an unknown output. They will not know. For the first example, they know the output will be apple, but of only the shapes, colors, they take it. So if I give a different color, it is able to find out it's an apple. But here I'm just, there is no training data set. So it will run again back and forth, and then it will find, and then it is classifying. There are 3 types of patterns available. One is an apple, one is a banana, and another is mango. Okay, so today, like we have got less time, so to the maximum, we have seen about we have seen what is machine learning algorithm, okay, and how it can be done, and then what it is to extract patterns. Okay, it learns patterns. It's a subset of AI, and then we went into the basic packages that we would like to know. It's about NumPy, SkyPy, Matplotlib, Panda, Seaborn, and then what are the steps? Okay, we saw about each and every functionality, a demo of it, and then we took a normal sales data set and we plotted it and just showed you how it could be done. And we have seen about COVID-19 data set, the different visualizations. So first thing, we have to visualize and analyze your data. That's very, very, very important. Okay, once you do, then you go into machine learning. You should correctly find for a particular application what is the type of algorithm that you use, and in that type of algorithm there are plentiful algorithms. We have to figure it out, and then we have seen the steps how we'll be doing a pre-processing, converting a categorical values into numerical values, and then we have to split your data into training set, testing set, before which we'll be splitting into a data and target. Then when we train with your data and training data and your training target, once you have trained it, then you test it with your target data alone. Okay, so once you train it, and then you have your target. Okay, you have your test target from your accurate results, that your predicted results and your real results. When you map it out, you will know what is an accuracy. And we saw about the performance metrics like F1 score, precision, recall, how it was truly positive, it was truly negative, and the different performance parameters were also being discussed. Any questions?
Thank you so much, ma'am. That was really a wonderful session on machine learning using Python. So we convey our heartfelt thanks to you for sharing your valuable knowledge with us, ma'am. So now, got the questions from participants side. Can we proceed with that, ma'am?
Yes, please. Yes, please.
Can you please run any one algorithm like predicting weather today, and tell what prediction is?
So for which I need to train. I have to write a code. Okay, I need to write a code for an algorithm. Then only I'd be able to show the prediction. But when you see if it is weather today, okay, when you see in your website a specific prediction algorithm runs. Okay, so I've got plentiful algorithms for different for different applications. Doreen @pepe.co.in. Give me a pen. Okay. So here, when you see today weather is 32, tonight it could be 28, and tomorrow it could be 33. Okay, for the next 7 days also it could be predicted. If you see for the month, so there is a prediction algorithm that runs the weather, what would be the humidity, what would be the temperature. So inside the website, the prediction algorithm runs. Okay. Okay, yeah, you will be able to see. Yes, please. Next question.
Yes, ma'am. The next question is, what is SVC?
Yes.
What is SVC?
Support vector machine. That's one type of an algorithm.
Okay, ma'am. The next is difference between random forest algorithm and SVM in machine learning.
So random forest, you take a cluster of you will take a cluster of data and then you randomly have some points and then you make it out. What was the next question after random forest?
And SVM in machine learning.
SVM is support vector machine. You have to create a vector from which you'll be able to classify according to the vector. Okay, you can randomize it and then you can use it also. Because nowadays here we are writing our SVM. When I did my post-graduation, I remember I wrote SVM algorithm for days and days until I got my results. But now your SVM is also inbuilt into your scikit-learn directly. You can use it. Okay. And next questions. Is there any more question?
Yes, ma'am. The next question is from Mr. Dinakaran. He has asked how to evaluate the model and how to improve the performance of the model.
Evaluation of the model, that is what I told you about the precision, the recall, right? The precision, recall, all the values. Once I run my algorithm, the precision and recall and F1 score will tell me how accurate. One of the first parameter that we will be seeing is called as accuracy. So when I split my data into training and testing, when I run my algorithm, in my testing, I will be giving only my data and not my target So when I give only my target data, after I run my algorithm, I get a predicted result. Okay, and then not only predicted results, I also have my original results. Okay, I also have my original results. So in my original results and my predicted results, both I will try to compare. That I also have my original result. So in my original results, okay, in my original, I'll get my original and then I'll find how accurate it is. So when I showed you the example, you're able to find some algorithm has got 71%, some algorithm has got 81, some was 60. So from which I'll be able to figure out, the values of it. So when I figure out the values of it, once it is less, I need to increase it. Once it is less, I need to increase it. So when I want to increase it, I need to do a model validation. For doing the model validation, we go for grid search or cross validation. The methodology is called as hyperparameter tuning. The methodology is called as hyperparameter tuning. Yes.
Okay, ma'am. Thank you, ma'am. Is there any specific websites for learning machine learning for beginners, ma'am, by Mr. Rajesh?
Yeah, there are plentiful websites, but you should know the path in which that you learn. Okay. See, the path in which where you learn is what you should learn afterward, because some people just dive into Python. Okay, and then they learn here and there, and when they get an error, it's difficult for them to respond. So there is not a specific particular site that I could say if you learn from experts, okay, then you will know after. We have a course right in our company. So first we start with basic data science with Python. Then we have to learn about data visualization. Then we go into a machine learning algorithm or deep learning algorithm, or if it is IoT, or if they want to learn about Django, because there is a path in which you have to start learning it. Okay. So when you learn according to the process, then it will be very easy for you to expertise yourself. And if you've got any more doubts, you can call me. My mobile number is here, and my company's website is here, cirf.co.in. And I've given the YouTube link, and there are plentiful like image processing for data visualization. You can see to it, and if you'd like the lectures, whatever you can give the comments in the session also.
Yes, ma'am. Thank you, ma'am. And there's one more question, ma'am, by Dr. Sumati. She has asked, on what basis we separate train and test data sets?
Yeah, I we don't split up the data set. Okay, the scikit-learn itself gives you a package. Okay, so that is train, test, split. Okay, so what it does, it will randomly take from random positions, and my data row on my data train. Okay, I have my data train and my data test, training test. Okay, so my data and target, both my data and target in my training and both my data and target in my testing will be of the same row with the same identifier. Okay, it is an optimized process. Only thing I can define how I want to split. Whether if I give 0.3, then it will be 70 to 30. Okay, it is a randomized process. And if I give 0.2, it will be 80% training, 20% testing. All right, if I give 0.4, it will be 60% of data will be taken. It is randomized. It will not take like 1 to 10. It will take from any sample data and then it will pull it into, but both my data and target will be of the same row. That is the specialization. So whatever it has been trained and split, I will not have any crossovers or any discrepancy in the data.
Okay, ma'am. We have got few more questions.
Yes,
We'll continue, ma'am. The next question is from Mr. Jayaraj. He is asked, is web crawler used in ML?
Yeah, you can crawl. You can do your crawling. Using a normal Python itself, you can do a crawling. After you crawl your data, if it is a text data, then you can go for text processing. Okay, say for example, we have done a research, like one of them have done a research we have done for a different application. I cannot disclose it because some research scholars also come here. We give you the training, they done do their projects on their own. But one more thing, what I have learned, I can share. So, you know, like US elections were there. So most of them, they had given different tutors. So they've done a web crawling of both Hillary Clinton and Donald Trump. So by that, how the people are giving comments. So the web is crawled and it captures all the data, and then when it is given into the machine learning algorithm, it predicted that Hillary Clinton will win, but Donald Trump won. Okay, that was a prediction, but actual was different. So you can use a web crawler. From the web crawler, you can fetch the data, and then you can do your processing.
Yeah, ma'am. Thank you, ma'am. The next question from Mr. Mohammed. He has asked, can you elaborate on feature dimensionality reduction techniques?
There are plentiful feature dimensionality reduction techniques available. I showed you in the slide, right? So like PCA, like what are the things that we want to reduce? Okay, what are the things that we wish to reduce? Okay, that is what we have to use different algorithms according to your application. I cannot say, see here, I can show you, like I've got LLE, spectral, like randomized PCA, kernel optimization. So many algorithms. According to my application, I need to use what feature dimensional metrics that I need to use it to reduce the data. And we have to, there are different algorithms for even for feature extraction. Okay, even for feature extraction, I can also manually do it, or I can use an algorithm, an optimized algorithm. That algorithm itself, if I give a data set of 10,000 rows and for 20 columns, at the end of the algorithm in feature extraction, it will tell me, it will remove maybe 7 or 8 columns, and it will give me only these 12 columns are needed. So that can also be done.
Okay, ma'am. Thank you, ma'am. The next question, how should we select the ML algorithm to improve accuracy?
That is what I said. When you write your ML algorithm, your objective, the first objective is accuracy. You cannot expect 100% accuracy. So if I take a data set, you cannot confirm with one algorithm with one accuracy. I need to run for the same application with the same subset for different algorithms. And then in one, even the same example I showed you, like one example we had, see for here the accuracy, when I used like KNN, can you see my accuracy was 81, but when I used my Gaussian A-base, it was 75. When I used SVM, the support vector machine, it was 46. So we need to train our algorithm data sets with different kinds of algorithm, and from which only we'll be able to find which machine learning algorithm is best suited for this application. And also here I've done only for one data set. Generally, I tell people to at least try with 2 to 3 data sets.
Okay, ma'am. The next question is, what is inductive machine learning?
Inductive machine learning.
Yes.
So we need to figure it out. Okay, I'm not very clear in that. I could learn to it, and if they could ping me up, I could do a survey about it and then get back to it.
Yes, ma'am. The next question is, I'm new to ML and how can I start my career with it?
So a lot of opportunities are there. In machine learning. Okay, a lot of opportunities are there in machine learning. Machine learning. First, as a beginner, you should know how to fetch your data, how to run, and there are different job opportunities available. But one thing I tell people before jumping into machine learning, they should be very clear in Python programming, and then progressively you can move. So once the basement is strong, then you can move into machine learning, into deep learning, and so much and so more.
There's one final question.
Yes,
in big data analytics, what kind of algorithm is best to use?
Big data analytics.
Yes, ma'am.
Yeah, in big data analytics, we've got plentiful. Like I have worked with Hadoop. Okay, in Hadoop we use a measure map reduce algorithm for some applications. See, for example, one of my researcher in my company, she just took like what I said, recommendation system also could be done. Okay, and also if I have my data set in my big data, I can run it. She took just the review words. Okay, she just took maybe I think 1 lakh of review text. If you buy a product, you say, right, even after this workshop, if I give you feedback, you'll say good, bad, what is it, so good, something like that. So from the set of sentences only we gave into a big data analytics using Hadoop, and from which we were doing splitting up of the words, and then we were able to figure out from the sentence. Okay, if I say good, it's okay, the product is good. If I say not bad, which means also the product is good, which means it doesn't mean the product is bad. So we have built in such a way, so whenever I feed into the set of review text, okay, the review text into my algorithm, all right, and it was able to give me, the 5-star, 4-star, 3-star, 2-star, 1-star rating. So from if after that, when we loaded even the 1 lakh of text, review text, it was able to give me all types of rating. It was almost okay for the text given. That could be done. Like a lot of recommendation system algorithm, prediction algorithm also could be run using a big data analytics.
Yes, ma'am. Thank you so much, ma'am. I hope we have come to this end of this question and answer session. And thank you so much for this mind-blowing session and sparing a valuable time with us, ma'am. It was really a wonderful session, and more than 300 participants joined in the session, ma'am. So do you have anything else to share with us?
Yeah, thank you all for joining the session. And in my chat, what packages? Just turn it out, right?
What package did you use?
Can you turn the monitor, please? Yeah, there are some questions from YouTube Live also, Abhinaya. There are different packages for mapping. Yeah, I've used Folium for different applications. For this such application, we used a different mapping screen, okay, for the COVID-19, because I have mapped it from the latitude and longitude, okay. There are different kinds of packages that is available to map for the COVID-19, not only for COVID-19, anything. If I want to have a world map or only for India map, I've got some applications, but we don't have time to show it. Okay, and I've shared the YouTube link of the session in the chat session. So if you find the session was useful, the best takeaway, you can give your feedback on the comment session. After the live session is over, you give the feedbacks here. Just 1 or 2 lines. If you find this was useful to you, you can click on to the YouTube link that I've given on the chat session. You can share your feedbacks in the comment box. Okay, thank you, Jayaraj sir, for the comments here. I wish most of you could give your comments on the YouTube feedback session. Thank you all for joining. You can see I've shared my mobile number. My mobile number is 900-30-21355. You can contact me through WhatsApp. And we also offer a course in CIRF, a full-fledged course for machine learning, for deep learning, and other things. And if you have got any problems, if you want to find some research solutions, we'll be there to help you out. And my mail ID, and I'll also put my mobile number and mail ID in the chat. Okay, my mail ID is doreencirf@gmail.com. My company's website www.cirf.co.in, and my mobile number is 90030213555. So we are richer, but we're able to reach many people. I thank you all for joining, and also I thank Nagaraj sir for inviting me, the entire department of ECE and the college, Saveetha Engineering College. I thank you all for the invite. Thank you all.
Thank you so much, ma'am. Thank you for this wonderful session, and thank you for joining with us today.
Thank you, ma'am. Thank you. Bye-bye.
We also thank Dr. S. Nagarajan sir for his effective coordination in conducting today's webinar. We thank all the participants for joining with us today. Hope you would have enjoyed the session well, and most of the questions have been answered by our speaker. Our upcoming webinar is on how to develop an embedded system by Dr. A. Rajalingam, Professor, Computer and Electronics Engineering Department, Chennai College of Technology, Oman, scheduled on July 3rd, tomorrow, from 1 p.m. to 3 p.m. I request all faculties and students to attend this webinar and get benefited. I repeat, our upcoming webinar is on how to develop an embedded system by Dr. A. Rajalingam, Professor, Computer and Electronics Engineering Department, Chennai College of Technology, Oman, scheduled on July 3rd, tomorrow, from 1 p.m. to 3 p.m. So the link for feedback form and e-certificate will be posted in chat box and in our YouTube live streaming page. Please fill the form and receive your e-certificates through mail within 2 to 3 days. I kindly request the participants to fill the feedback link with correct mail ID. Participants kindly complete filling feedback form within 15 minutes after the session gets over. We'd like to inform that feedback link will not be shared through WhatsApp or mail. So meet you all in the next session of our webinar series, and thank you all for your wonderful participation. Stay safe. Thank you.